Okay. Okay, so what did we do last time? We successfully mapped the portions of the textures onto the tiles, did a bunch of other stuff, including command line utility, so we don't need to use the internet when we want to do a quick color conversion. So today I want to start polishing up this game. Kind of basically, it's almost done. However, there's a couple of things to do first. So the first is that there's currently an unnecessary extra border around this. So for instance, if we go into the colors and I set the grid border here to be debug instead of black, and then just compile and run it again, we can see that it doesn't really add anything to the game, and so we should remove that extra geometry. No need for that in the code. That also simplifies a couple of the calculations. Another thing that I want to do is a small thing, adjust the color of these tile borders. Currently it's a kind of charcoal gray. It's not like super noticeable, but I think it would be, it's something we can tinker with. And also, why is it taking so long to build in debug mode? Is the cache just blown? How big is this cache? It's already half a gig. No, we can't, that's not acceptable. Let's just build it fresh again. Yeah, so those are like two smaller things. But the main thing is that we want to detect when the puzzle is complete and then do some kind of animation, trigger some kind of win state. I was thinking about this last night and I kind of realized that we could actually completely remove one of the shaders. We can remove this solid color shader and instead do the following. In our shaders, if we go into the texture fragment shader, we could actually have another argument here. We can basically linearly interpolate between a solid color and the texture. And so for this like completely white background here, I was thinking a really nice win state would be to like dissolve all of the grid lines and just kind of go back into the underlying image. We could easily do that by linearly interpolating between the kind of current texture here as well as the solid color. That would mean that we can actually get rid of this solid color buffer, and when we draw this background, we just we pass in a different argument to the vertex the vertex shader in this case. Some other parameter that just controls like the amount of linear interpolation. And then similarly for these borders around the tiles, we could just do a similar thing. So in fact, well, now, yeah, because if the idea is that we want to at the end of the game fade out all of the borders, we're going to need to transition both the background here as well as these border colors. So okay, up until now I've just thought in my head combining these like interpolations would be easy in some way. It probably is worthwhile planning that out now. But yeah, the other thing is like the win state, and so with all of the like inversions around the y-axis we've been doing in order to get the image the correct way up, I'm wondering if in some way we've fudged like what the win state should be. The win state should just be where the tiles are labeled 0, 1, 2, 3, 4, etc. So I think actually a first thing to do is just to check that out. So we did have like a debug print function for the tiles, which was one of the very first things we wrote. Hopefully I didn't delete that. That would be a bit annoying if I did. What do we call it? It was just called debug print, right? Yeah, debug grid print. Here it is. So I think currently I want to print this out at the end of every time the grid is updated. So let's see, if we go to process update state, here is where we'll determine if the underlying grid has changed state. Oh, we also need to factor this out as well. This is kind of nasty. It's doing a lot of the same thing. Let's see, if the state isn't updating, the block is immediately broken. And so if we go just before the end of this, so Control App P, isn't it? And instead do a debug print here, debug print grid. This should then give us, should tell us what the underlying state is. Actually, to make our life slightly easier, let's change the grid dimension to 3. Okay, so if we just solve this now, and I've spent this time making the game, I should actually play it, right? So let's move those around, and then that in here. Yeah, this game is like harder than I thought it was. Okay, so this is almost solved, and let's see, is this state here what we want? Yeah, we do want it to be 0. So yeah, if we were to swap the 2 and the 3, this would be solved, and this is what we want. Okay. So we can just basically trivially program a win state, which is just to check if the grid is itself the number 0 through to the grid dimension squared minus 1. And then if that's the case, we can say like 1. So yeah, let's do that now then. Cancel this. Ooh, so yeah, we should. So I'm in two minds. The first is that it's actually time to just do this grunt work of factoring this switch statement. Like, the game is clearly working now. We've delayed addressing this since basically the very first stream. I think the time has come to tidy it up. And then once we do that, we'll get the reward of writing in the win state, adding in the animations, and having things look nicer. Okay, so what are we doing? So we're seeing if the tile has been pushed in some direction. And then depending on the direction, we then check if it's actually going to update the grid. If it's not, we break, and then otherwise we update the grid. So basically this, it looks like this code is just like, it's almost the same in every case. The only thing that's changing is the condition inside this if statement and this like swap tile index. Okay, so how should we do this? So are we returning from this entire function? Yeah. That itself might slightly throw a spanner in the works, but it's okay for them, like once we do the win state animation and stuff. But I guess it's fine now. Yeah, how do we want to do this logic? Let's factor out the if statement into a switch called like update grid or something. And then we can just switch that, have all of the if statements. And then if that's true, we can then do another switch. Where we're, yeah, that would factor out all of these if statements, break us from the block, and then how do we factor out the second part? I think we just have a switch statement that computes the swap tile index, and then I think everything else is the same. Okay, except the animation direction. Oh, but the animation direction is the same as all of these, and so that should be really easy to set. Okay. So let's back to this. So I think we want to first determine what basically this if condition. So why don't we call it like grid update, and then we can switch on the tile movement direction. If we have a none, this is clearly a false. If it's up, we just want to return this condition. If it's left, we just do the similar conditions. Wait, something's clearly wrong. Why? Oh, no. I was like, why are these the same? But they're not the same. One is .x and one is .y. Down is empty tile equaling a 0. And then that leaves us with right, which is this. Oops. Okay. Okay, and then we simply say if not grid update, then we want to return. And well, I think for the moment this is okay, but we might have to come back to it. So otherwise we are updating the grid. So then we want to, in all of these cases we have like animating tile equals 0. What's the point of this? Oh, I think this is actually, I think this is grid not update. Let's see. If we're pressing the up button and let's just press that. If we're pressing the right button and so we want to fill in a tile moving to the right, but we're on the x-axis, then we're not actually doing it. Okay. So rather, what we really want to say in each of these is update the grid if these things are not the case. But now there's like, let's just call this no grid update. Easy to follow. If it's no grid update, do that. Otherwise, we're updating the grid. So then we want to switch on the tile movement direction again. And then what's this thing we want to factor out here? I think we want to factor out the tile swap index. Since then we're saying, yeah, set the empty tile index to that thing, set that index to 0. I also feel like just for readability, this should make it explicit what that is. And then, yeah, likewise for so we want to say yeah, swap tile index to size is equal to switch the tile movement direction. And then if we have a none, then it should have never been reached, so it's an immediate fail. If it's up, then we want this thing. It's oh, what did I just do? This, if it's left, then empty tile index +1. And then if it's down, empty tile index minus the grid dimension. If it's right, then this thing, and then that should be that factored out. Okay, so now let's see, we can get rid of a lot of this. Oh, this animating tile equals 0 though, we should, this is important. important. We should add this back in. Because I think this resets the animation if you've updated the state and then you can't do anything again, it's gonna kill the animation. So we want to say animating tile 0 to 0. Okay. All of that. So now we just want to use this code, basically. Oh, I'm so happy. Like it's really good that we're factoring this out, and like the factoring is again, not that performance necessarily matters in our case, but this is like way less instructions. It'll be way faster to load these instructions into the program. Okay, so then we say, yep, but for this animation direction, we now want to set this simply to the tile movement direction. And I think that's it. So let's then clear out everything. It all fits on one page now, always a good improvement. And yeah, let's give it a run. Let's give it a spin. Unused block label. Oh yeah, I guess it's we don't even need a block anymore. Oh dear. That is not good. Yeah, what happened? That's really not good. I wasn't expecting a program crash. I'm just refactoring this. Okay. Oh, we're reaching none. Uh-oh. How? I thought we were returning. Oh, because no grid update should be true. Okay, game almost working, but now there is no animation. So we need to fix this. Okay, what about this just stuffed up this animation system? Let's swap the order of this. Could even do a git diff and just check it out. So okay, so what did we have? Oh, okay. So I think it's when I think for the very first frame it begins to animate, and then since we haven't pressed the key immediately again, it then triggers this and sets this to 0. Okay, so because when we get a none up here, maybe this is where we should just return it. Will the Z compiler even allow this? Okay. Okay, back to normal. Okay, so that's that refactored. Wasn't really that hard at all. As these things often go. Like, this game is hard enough when it's like 1 by 3, let alone when, I mean 3 by 3, let alone when it's 4 by 4. Anyway. Okay, so then, anyway, let's move on to the like animation, the win configuration state now. To make it faster to test, let's just set the grid dimension from 3 to 2. But we'll also set what the grid actually is, since for some shuffles it will result in an impossible puzzle, as we figured out last time. So in the init grid, let's just very temporarily set the grid to equal what? It will be solved when it's 0, 1, 2, 3. So we want to shuffle this forwards. Instead of just like guessing, let's literally just use the game state .debug printing to tell us what this is. So let's just shuffle it a bit so that it will like win as soon as we press a single button. And so we want it to be 1, 0, 2, 3. 1, 0, 2, 3. Great, and then this will allow us to easily test it, the win state. So now let's add in a win state condition. So to update state, just refactor this. We should add in some comments here. Update, see if the grid, determine if the grid needs to be updated, and then update the grid. Now check if the puzzle is, oh, I realized, I think like the Twitch, I think like random thought, I think like the Twitch stream description is a bit weird. We should call this like finishing up the puzzle game, not wrangling fragment. Finishing up the sliding sliding puzzle game. Or maybe like wind state detection and animation. Okay. So yeah, so now we want to check if the puzzle is solved. So we can just say is one. Oh, it may be useful to have a global state that determines this. So let's go to our globals. Where should we put this? You could just make another category called game globals. Maybe the best way to do it. A game. Actually, it looks like the global start here. So you just say is one, and this will of course be false to begin with. Then we can just say is one is equal to whether the grid is equal to is it like simd.iota? Yeah, simd.iota tile number, and then we can say if is one, we want to print like game one. Well, oh, that's what we need. So yeah, let's check this now. Okay. Expected bool found. Oh, okay. We're doing a a vector comparison, which is fair. We just then want to reduce with and this thing. Okay, so then yeah, we got game one. So if we do a lot of these, great. Okay, that's working. So now we want to I guess we now want to get into like the animations, and yeah, like our project is nearly complete. This has been satisfying. Like, it doesn't feel like we've spent that much work on it, and we've already built a game from scratch with like custom shaders and stuff. It's satisfying. Okay. Yeah, so what do we need to do? So my idea was to modify the fragment shader. Oh, we could even do it with a uniform. Yeah, I don't know why I was thinking of adding in like an extra argument into the vertex shader. We can just do it with a uniform. A uniform that controls the degree of linear interpolation between a texture and a solid color. Okay, I guess we'll technically need two uniforms. We could even make one of these uniforms just a direct color. We could simply that would be a really easy way to set both the the background color here as well as the top border color. Okay, so let's try that then. And then, yeah, once we get this working for the texture tile, when you step back a bit, so let's modify the current texture shader to do this. Once we've got it working on the texture shader, oh, you know what? I actually realized this means we can completely cut out the. This basically allows us to draw the empty tile. We don't need to worry about having like a. Okay, I guess not that actually matters, but okay. In fact, we don't want to necessarily draw, and it would just be a way to simplify the code that you don't actually need to check the. So yeah, once we modify the texture shader, we'll then want to add to the draw cause for the texture shader the like the inner rectangle that's currently doing this background. You know what? Actually, before we get there, we should remove this unnecessary border that's currently being drawn in black. That will simplify the code a bit. We'll do that first, and then we'll do this stuff with the texture. Okay, so currently we have this outer grid rectangle, and we don't want this. So we can actually get rid of a lot of. I think we can get rid of a lot of the outer grid calculations. Yeah, we can just get rid of this. Where does this get drawn? Down here, get rid of that. I think that's it. Okay, yep. It was as simple as that. Oh, let's get rid of this and then save it. Outer grid width. And now we should probably rename like the inner grid width to something. But we've already done a bit. So let's save what we've done so far. So I'm going to say there's like cleaned up code and added in waiting condition. Cleaned up code, added in waiting condition. Okay. So now let's rename this like inner grid width to something more sensible. Maybe like background grid width, or like total grid width, or maybe just grid width. There's no need for inner and outer if it's just a single thing. Yeah, we'll just call this grid width. Okay, so we want to replace inner grid width with just grid width. It's already pushed. Come on, just build it. Z current build run. Okay, still working, great. So now we do the texture shader stuff. So let's go into our shaders, into the fragment texture, and start adding in this uniform. So to begin with, we'll just add in we'll make the color it's going to interpolate constant. Then we'll add in another uniform to set like the color it will interpolate to. And we'll need to look up the OpenGL function that does that. But currently we'll just have a float called list lambda, And then we want to interpolate this. So let's say, oh wait, this is, I'm going to say texture color is equal to this thing. And then we want to say, well, really, this is a vector. And the vector interpolated color, this thing is going to equal this is where the lambda comes in. The lambda, I think, should be, oh, how are we going to do this? I feel like 1 should be texture and 0 should be like no texture. Okay, in which case we'll do lambda time, we'll see if OpenGL is okay with this kind of thing. Texture color plus 1 minus lambda times the fixed color we want. And so let's just set this to be white to begin with. And then we'll set the frag color to be this interpolated color. To begin with, while I want to see if this line will compile, let's just make this a constant float that's equal to 1. And we shouldn't, okay, let's change it to 0.5. And then we should see a, yeah, we should see this. Everything's kind of been faded, which is good. So now let's try and control this with a uniform. So we need to go back into our current program and find the location of the of this uniform. So let's do, actually there's a lot of functions here we want to copy. Copy that to, save that to 1, save this to 2. So yeah, when we're drawing these tile textures, let's see, we want to update the uniform where, probably after we call it. So let's say lambda shader location is just lambda. And here we're getting the location of the texture shader. And then we want to set it. So let's now set a well, we can put this on a sine wave actually. Let's set this to be, like we've already calculated the time above, right? Yeah, we've calculated the program seconds. And so let's say lambda is equal to 0.5 plus 0.5 times the sine of the program seconds. Then we should be able to see the grid colors pulse. Great, and yeah, this is what I'm thinking for the win state. Like when the state is 1, this is happening, but instead of this happening to the tiles, it's happening to the background. And the background will actually fade to like an original copy of the Earth. Okay, great. It's working so far. So now we want to we want to kind of like sunset the So the thing here is that we've got if we are going to be using this shader for both the grid background and the current tiles, we're going to need, like in some cases we will want to be using this value of lambda. In other cases we want to be setting it to, like in some cases the lambda will always be 1, in other cases it's going to be the thing that changes. And so yeah, now I'm like confused as to how we can do this. I suppose one thing we could do is just update the uniform several times. That kind of feels, I was going to say that feels nasty, but actually maybe that's totally fine. I kind of like the idea of just like pushing stuff to the GPU and then leaving it alone, but maybe it's fine. Like we're hardly rendering anything at all. It won't have any significant impact on performance. Yeah, it's like easier to understand, so let's just do that. We'll update the float several times. So then, okay, so now we'll need to add in another float, another uniform, which now represents the kind of the color that we're interpolating to. So let's just say, let's call this like interpolating color. Yeah, we'll make this is vec4. We'll make it pure white for now. But we want to make this a uniform, so we should look up how to do that. So what's like the name of these functions? It's like uniform1f or something. Yeah. So GL uniform 1f. But in this case, it's going to be like will it be 4f, just for 4 floats? Okay, and then we actually just specify them one after the other. Okay. So in here, for the draw the tile textures, we'll want here one interpolating color, which is, we want this to be 4 F32s, and let's set this to be this to be a different color to begin with, just so it's clear that the interpolation is happening. Let's just make this magenta. So then we want to say interpolating color location is just equal to this thing, interpolating color, so therefore GL uniform 4F really should be interpolating color shader location. And then just the values. So it feels a bit silly to just we'll call this like IC. IC0, IC1, IC3, IC pi. Call that. We'll make this a uniform. Okay, let's try and compile this. Nothing called uniform. Uniform. There's some lines. You could write some poetry with that. Like uninformed, uniform. Lots of potential. Okay, great, that's working. And so now we're now in a position where we now have a generalized shader that will draw both of these tile textures and this background grid square and these tile borders. So it's just a matter of setting the stuff. So here, how will we do this? So when we're drawing the grid and the tile borders, we're going to have to replace these flat color VAOs with the stuff that we want. So the stuff we want is we're gonna have to, so currently the data of this is the positions and the colors. We now only need the positions, but it's gonna want positions and textures, so we can just use really any like dummy values of the textures, I think, because again, it's not our shape. Actually, that's not the case. If we're gonna want to fade everything, then the texture values are going to have to be what they actually are. Okay, maybe another option is simply to do like is to simply modify the opacity. Maybe this is actually easier. We could just have a uniform that determines the opacity of the maybe the draw core order is this. We draw the background texture, then using the texture shader, we switch shaders to these color ones, draw those, then we switch back to the texture shader, draw the tiles, and that's always what happens. And then in the win condition state, we then use a uniform to adjust the opacity of this stuff. Okay, I think this might work. This might work a bit better. But let's do an experiment. So let's go into this and, well, let's set the lambda. Also, why was the lambda here like 0.5? It's uniform. So let's make the interpolated color here magenta, but the final coordinate is lambda. So then we're just adjusting the opacity directly like this. Oh yeah, because like this final coordinate isn't the opacity, it's like the yeah, it's like OpenGL's thing where you have to like enable alpha blending and other stuff. It's like it's basically it's a different coordinate system. Okay, so that's not working. So let's go back to that. Let's go back to the original idea. Okay, so it would be easiest to do this with alpha blending, but whatever. So we're doing, what are we doing? Yeah, so if we truly want to fade everything, if we're fading both the borders here and the background, we're going to have to, the background is going to have the correct like texture in order to interpolate to, and the tile borders are also going to have need to have the correct texture to interpolate to. Okay, that means we have more fun calculations in terms of all of these like tile widths and stuff. That'll be fine, we'll get through them. So yeah, so I kind of want to get this working for one of these geometries, but I kind of want to get something working before we do all of the geometry calculations, since we're going to be removing this flat color vertex buffer and just using these other ones instead. Okay, so we're gonna have to switch off some stuff. Let's work our way back from the render. And what we need to switch off here. Okay, so when we're drawing the grid and the flat tile borders, the order we do things now kind of matters. We could have two vertex buffers. One, we could actually basically retain this color vertex buffer index, but maybe it should maybe we should update it. Okay, there's like a couple of things. One is that we have like a single buffer index with all of this stuff. We just remember how many vertices draw the stuff that we are not interpolating, and then we we just like remember that, and then we call the same buffer. We basically call like to draw the buffer twice, but we just like offset it correctly. That feels like it's going to be a pain, and there's like a chance for potential bugs. It's easier in my mind if we simply say this vertex buffer is for the stuff that's usually a solid color, but we are going to transition at the end, and then this is stuff which is always going to be like the textures, and then yeah, to me that works. That works easy in my mind. But yeah, I've got a text message I should respond to. Okay, so let's do this then. So we do want to do our texture DAO, and the buffer we bind will be the texture. I feel like we should really be calling this something different, like the color texture, but it's fine. It's fine. Then we want to be using our texture shader. Yeah, push stuff to the buffer, but in this case we want to be pushing. Why don't we keep that? We can actually keep the names the same. The color vertex buffer index. It's just now it's going to be yeah, it's going to be 4. Why do we need to pass in a 4 here? Oh, this is the size. Yeah, it's 4 floats per line. So the overall size is then 4 times the number of lines. And then we're doing that. And then yeah, we draw these triangles, which is fine. But before we draw these, we need to update the uniform values. And so hang on, so I guess here's the problem. If part of me thinks it would actually just be easier doing this with like no uniforms at all, and just like passing in a bunch of data. Like we just have the colors, the texture coordinates, and then some interpolation value. It's fine. Since if the very first thing we draw has like the white background, and then everything else has the gray tile borders. Wait, actually this is something randomly I want to do, which is just to see if the z cache increases every time I compile it, even if I don't modify the code. This is some random thing that I just want to experiment with. Okay, so let's see. It's currently that 215714. Okay, it isn't increasing in size. This is good. See, it gets so big so quickly. Yeah, we are going to have to like offset these and draw them at different places. Okay, what does the second argument in GL draw? draw arrays do? You move from Odin to Zig, or do you still use it? Yeah, I use Odin like occasionally, but now I'm basically using Zig. Yeah, like I've kind of realized that this is for a number of reasons. All of these reasons it's hard to summarize them quickly. Actually, maybe it's not. I'd say it's rather like for a lot of software I'm making now, while I make most of it in Zig, I do require some C interoperability, and it's significantly easier to do this in Zig than with Odin. With Odin, many times it's possible, but sometimes you have to sometimes it's just really hard. Also, in Odin, there's basically no comp time. There kind of is for some trivial values, like you can just say, like delta is like 3.2, and then it's just like, it has very, very crude macros, but in Odin you can't even say like lambda is equal to the square root of 2, where the square root of 2 is some function in the standard library. Like Odin will refuse to calculate that. And likewise, weirdly, with some of like the vector operations in Odin, it also like basically refuses comp time. Like you can say, this is like a super pain in, like this is something I was always annoyed with Odin. Like you can say like list 1 is equal to some fixed vector, and then it is like, and then you could say, and it will like remember that at comp time, and then you can kind of use it. But then if you say like, if you define 2 of these and then like add the vector, it would just like refuse to compile. And I'm like, come on, like this is, if like Odin's version of comp time will recognize like 2 separate integers, and then you can add them together, and that thing will also be comp time, why is it confused about adding vectors? Like, ridiculous. So yeah, Zig is just like way more powerful and better with regards to this. And then there's like there's so many other factors, like the build system, and yeah, there's a lot of stuff. I do wish Odin the best, and I do want to see, for a lot of small and simple applications, I think a lot of people would be better served just writing stuff in Odin. But for like big scale things, like the current, not the game I'm streaming, but the game I'm working on off stream, for something of that scale, Zig is again like you still can do stuff with Odin at scale. Like if you've seen basically any film or TV series within the last 2 years, that if that has any kind of particle effects, those particle effects were made by a piece of software written from scratch in Odin. Maybe you already know about this, but like if you saw like June 2, for instance, or even like June 1, almost certainly so many of like this is Embergen demo. If I go to like, almost certainly any of the where's like something recent within the fine. Let's just go with like any of these will be fine. This one, like Odin is like powerful enough to make like an enterprise level software for like generating for this thing here. Like people do stuff with nodes and then files generated. It's like way faster than it's like currently stuttering now. It's like because this is old. It's like it's fluid now, but it's yeah. Zig for me is currently, I feel like is currently the right choice, but who knows? It may be urgent in the future, but it's hard to say. That was such a rant, like long answer, but it's complicated. It's complicated. The best way to figure it out is just to like try both languages for a moderate sized project, and then after like 3 months you then start to like go, yeah, you start to see how the projects are, how the programming languages are and their tool chains are appropriate at scale. Okay, so yeah, so back to this. So yeah, we want to do what do we want to do? Yeah, we need to figure out how, wait, we were looking up the GeoDrawArrays function, and yeah, what's this second argument doing? Code first. The starting index in the enabled arrays. Is this the index of the byte, or is this the index of the row? I guess we'll have to determine it. Probably the row. Okay, so yeah, so we'll draw this where this is like number is like 0 and this is 6 to just draw the two triangles for the background grid. Then we'll need to update the color uniform, update the rest of it, and then I'm feeling like queasy about this, that we're like having to just do all of this uniform juggling. No, yeah. Honestly, like the conceptually easier thing in my head is for there to be like a single draw arrays function, a single buffer, and I think this is how it's going to have to go. Like, we just create a single buffer, and that buffer is responsible for all of this stuff, and so we'll just create we'll modify the shader so that there's actually no uniforms. And everything is just loaded into the data we push to the GPU, and then yeah, we simply manually set each time what the opacity is, what the colors are, and then the GPU just handles all of that. I think it will be the correct approach. Okay, so let's change the text. We need to change the name of some things. So instead of texture shader, I kind of want this to be called like color texture shader. And then we're going to have to modify this texture vertex. So we need all of this stuff, clearly, but now we need the colors that we want to push to the GPU. Let's see, red, green, blue. The A value will always be 1 since we're doing the interpolation and controlling the shift that way. But we also need the like lambda for the switch. Oops. Okay, so this is like a big change. It's a big change that we're making, but it will simplify everything. Let's just go with it. It means there'll actually be like way less code, way less things to understand and juggle. And it also means when we like translate this, translating to the Serenum, so many things are going to be different. But at least if we're like translating this to the web, if we just have these like a single buffer, only 2 shaders, things will be easier. So let's call this the color. I feel like calling this like color texture vertex now is like slightly. Should it be the texture color vertex or the color texture vertex? I feel like it's textures first and then colors. But then color texture vertex just feels kind of right. So let's modify that. Okay, so we have the positions, the colors, the texture, and then the lambda. Let's call it alpha lambda. So then we have color, texture, vertex. RGB, TY, and then the lambda. And then, dot R is R, dot G is G, dot B is B, that is that, dot L is L. This game is the right instance where the number of triangles drawn each frame is the same. This is still going to be correct, especially when we're putting everything into one buffer. So we can come back later on and deal with that. But for the moment, we have our color texture vertex buffer. Color texture vertex buffer index. Part of me wonders if we can just call this the vertex buffer index. Now there's only one thing. In which case we may even just be able to call this the vertex buffer. Like, yes, we are kind of, to draw the background we have to draw a bunch of other geometry anyway, but that's static. Yeah, let's just call this the vertex buffer, since there's only going to be one thing. And then all of those are the same. When we go to now like compile the shaders, in compile shaders, this will change. So now we're not using this flat color shader anymore. It's now just this vertex. This texture shader. But yeah, in which case we should call it vertex color texture and fragment color texture. Vertex texture, vertex color texture, GSL. We're gonna have to then update the names of well, these things. Don't need those anymore. Yeah, let's do both of those. Maybe we can just, no need to outline this. Okay, but isn't this called the texture color shape? The color texture shader? Yep. Okay, I'm like totally now committing to just like deleting everything else. So let's do that, just clear it out. So we'll come back to this and like figure out exactly what the number is, and then we can just this will basically enable us to forget what the we won't even need to like keep track of this index. We should just be able to pre-compute everything in advance. Well, like this clearly not true, but it's rather the memory layout won't be like going like loops will be simpler and take less instructions. That's the way to say it. Okay, so yeah, init grid, simplified all of this. Yeah, clearly the decompression is working. Sliding puzzle. Maybe call this like sliding puzzle game. Don't need to adjust that input. We've already cleaned up the update state. We'll be testing this soon once we transition everything over to the shader. This stuff now needs to change. This is now just the texture buffer index, right? Oh no, that is not the case anymore. What did we call that? We just called it vertex buffer. Okay, the vertex buffer index. Yeah, well, that's fine. Okay, so here when we're drawing the grid and the tile borders, yeah, this is where we need to use this other stuff. So we can get rid of the flat color, vertex array objects and buffer objects. I feel like we should be calling these like color, texture, and etc. using the color texture shader. Okay, so now we have the vertex. We need to be clear with what we're pushing here. Well, right. The purpose of having of modifying the data we're pushing is that we don't actually need to be careful with the parts of the stuff we're drawing in the code. We just push everything, we draw everything, and it's immediately done. So yeah, push the data and draw it. Yeah, I feel like it's so often in programming school, one, people never really talk about simplifying code or optimizing, but then once you just realize this is so much of programming, at least if you care about making quality software, there's then this question of which parts do you simplify? You can really simplify everything. It's always simplifying this part of the base makes this part complicated, or this part complicated makes this one complicated. And it's always I feel like I wish I had a bit more guidance on this, but it's so much just a gut instinct, I think. And then that should kind of be it. So all of this other, well, nearly all of it. So let's see, this, that can go, that can go, that can go. This stuff can go now, since we're pushing it. This can go. This stuff we absolutely need. In the same way, we really should be updating the location of this stuff. So yeah, make the texture active, bind it, get its location, update the uniform with it, and then that should kind of be it. Okay, so instead of color vertex buffer, this is now just called the vertex buffer index, right? Yep. Okay. I feel like I just want to keep this commented just in case we need to use it again. It says the names of functions we want to look up and everything. Okay. Get rid of this. This is now just a single line. Oh, if it's a single line, we don't even need these brackets. GL commands maybe move to a separate proc. No, that's fine. This stuff we'll want to eventually change, I think. We may want to, this is another annoying headache admin thing to deal with. Making the size of the window adjustable. It's currently if we make it bigger, it's just adding in again part of me doesn't feel like the effort to do that is justified. It would be extra programming work, but then we might need it when we put it to the web, in any case, we can cross that bridge when we come to it if we need to update it. No, don't want to do it now. So when we're drawing the background, we absolutely need to update all of that stuff. I feel like these calculations should be done before we call out to like GL. Like we want to do doing all of the GL calls one after the other. So let's do set uniforms. And then we set the LP value. We will eventually do this to do once we get all the rendering in order. Okay, and then we want to set is not the best word. Calculate is better. Calculate the uniforms. Now we can say set uniforms, and then draw a background. Maybe render. Draw background triangles. And maybe we should call this render the background. Okay, and then here we want to render the grid and tiles. So now we're using the color texture stuff. Bind that. We'll get the location. And draw the triangles. Well, we know what's happening in those cores. I guess we can say push the data. Draw the grid and tile triangles. Okay, so that we've got simplified a bit. So now we have to do the this calculation. Oh, this is such a big rewrite. Such a big simplification. But it's a standard part of development. Just like any competent author edits their stuff, any competent programmer will edit the code they write. Who would just write code and when it's barely working, push it out on the internet, right? Okay, certainly OpenAI wouldn't do that. So let's do DeepSeek does not do that. They put out quality stuff. Okay, let's do yeah, let's handle this grid geometry stuff. So yeah, so we're now gonna have to calculate the relative positions for everything, and then kind of set colors and lambda values and other stuff. So we can bypass calculating the coordinates for some of these and just use dummy ones, but eventually we will need to set these. So let's delay the geometry calculations currently and just get stuff working with a single shader, and then we'll come back and do it. So for these draw color rectangle in a grid rectangle, this is another case where we don't need the inner. I thought we got rid of that name. This is more comp time stuff that could be factored out. Maybe it's fine to leave it. Okay, we do all of this. So we're just passing in the grid rectangle and then the color. So let's check out what draw color rectangle is doing. We're gonna have to update this. Yeah, so instead of the color vertex buffer, it's now just the vertex buffer and the vertex buffer index. And this color vertex function will need to change. I guess it's been deleted. What was it called? Vertex. This is called color texture vertex. So so what's the type of the color texture vertex again? Yeah, we want to X, Y is important, then we have the RGB, but now we need to add in the coordinates that we will be calculating. Or should we add those in? Draw color rectangles itself, not really the best name. Draw, I think it should be called just draw color texture rectangle. And then in a similar way that we were passing in the, what's it, like top left, what's that function where we like pass in, yeah, the top left texture coordinate and the bottom right texture coordinate. The function name is long. Anyway, top left texture coord vector, and then the bottom right texture coord vector. And then let's alias those names. And then let's see, yeah, we want to break those down. And now we want to send these to the GPU. Let's just do these in order. If we're doing the coordinates of these first, then the colors, then the texture coordinates. We're then pushing, there's then also the lambda value that I guess we really should be passing that in as well. Lambda, which is just an F32. And Okay, so yeah, so the nodes we're then pushing to the GPU are those screen positions, colors, now the texture coordinates, which was like, we just basically want these to be the same, right? S left, T top, then the lambda. This is already taking up so much space. S right, T top, lambda, S left, T bottom, and then finally S right, T bottom, lambda. Okay. Got all of that. So now we need to go back to draw color rectangle, and now it's draw color texture rectangle. So for the moment, let's pass in like dummy top left and right coordinates. And okay, for the lambda value, if the name of the function is color texture, I think 0 should correspond to color and 1 should correspond to texture. So we'll set the lambda values here to be 0, and then we'll modify it in the shader. So we've got that going. This is another draw color rectangle. So there's so many. This needs more comments. Compute the tile rectangles. So that's done. And then we want to say draw the grid background. And then here we want to, wait, do we need tile border rect width? Oh, I guess we do. We do this many times. Okay. Draw the this is draw the tile borders. Draw the tile borders. But we're kind of drawing the tile as well, since we're drawing the texture here. So I think just draw the tiles is a better description. Yeah, no need for like sending the tile to a particular color. Let's just eliminate that from the code. Okay, so draw color texture rectangle. When we're drawing the tile borders, again, who cares at this stage about what the texture coordinates are? We will need to worry about them eventually, but we'll just set them to be the pure color now. Then we want to draw the inner thing. So draw color texture rectangle. Now for these ones, we don't care about the color, so we can make this color.debug. actually can do that, right? We do have a debug here. And then these ones we want to do the full entire texture, which is a 1. Okay, and then so there's a bit of a if we want to just like check that this is working, when we have this value of 0 here, this thing is going to be changing when like the win condition is 1. So I think if anything, we should define something called like win lambda. But now we need to do like the program second calculation. So maybe like solid color. I guess we can call lambda here. We should calculate what this is. Program seconds. So let's just make lambda thing we were doing before. We don't need this anymore. 0.5 plus 0.5 times the sign of the program sex. And then we'll just pass in to the grid background what the lambda is. Then when we're drawing the tiles and the tile borders, we also want the lambda here. But otherwise, it's going to be constant. And oh yeah, draw the animating tile if non-zero. Yeah, this is what I was thinking. Like maybe there's a way of not trying to avoid some of these calculations, but maybe not. There's going to be so much copy pasta, but all of this calculation was required for. I feel like this itself can be refactored in some way. Or maybe not. Actually, yeah, I feel like when we were programming this, if there was an easier way to do this, we would have come up with it. Like I think it's easy to think about it in terms of the rendering and positioning and that. Like, if something's animating, draw everything else and then figure out the animating part. Otherwise, just draw everything standardly. If you don't do that, you would then say, if something's like not animating, then we'll keep it in. Draw color, texture, rectangle. So animating tile border rect, tile border. We now need the texture coordinates. So again, we'll just make this to begin with, and the lambda, and then draw color. It's draw color texture rect, isn't it? Colors.debug, the actual coordinates, and then a 0. No, it should be 1. If it's color texture, we want one to represent the full thing. Yeah. Okay, how are we going for time? We'll see how close we get. It's going to be close, because yeah, I want to finish this in 15 minutes. So yeah, we don't need this draw texture anymore. When we're now setting up the buffers, that can go. So why is there two? It's gonna go now. Okay, yeah, we're doing the size of the vertex buffer. Okay, so here we're gonna have to think about how to split these up. We're gonna need way more now. So we have the we've got the 2 position coordinates. We then have the 3 colors. Offset by 3. We then have the 2 texture coordinates, then offset at 5. Then we have the one float. Let's see, what offset is this? 7. That represents the lambda value. So yeah, we should have 8 in total, right? Vertex, color. Color, vertex. What's the name of the struct? Color texture. Yeah, there's 8 there. Okay, let's just enable all of these, obviously. Generate the blue marble texture, bind it, texture stuff, more texture stuff. Okay, I think that's kind of it. Then okay, so now we need to actually modify the shaders themselves. So now when we go to the vertex color texture, we want, we've got lots more layouts. We now have 2 and a 3. This is just a float. The second one is the texture coordinate. This is the vec3. This is now, say like the A color. So now, let's see, what are we doing? What stuff are we putting out? We're putting out everything except the position. Color tech coordinate, and then call it lambda. And I guess since luckily all of these are different types, we may not have to do location stuff. I guess we'll see. Do all of that stuff. and send the colors on. Lambda is equal to a lambda. Okay, so now we do the fragment color texture. So now we've got a lot more things that are coming in. So we've got why is there weird alignment now? We've got the color, the tech coordinate, and then the lambda. Okay, we can now eliminate those. That was the entire point of all of this refactor. Yeah, so this project is targeting two things. So the first thing is that it's targeting the web, and then it's also targeting a extremely niche operating system known as the Serenum. So instead of building the entire thing on the Serenum first, since development there is significantly slower, I'm just building it on here on Zig. Then I'll port it to the Serenum and then to the web. So yeah, so I have a so basically with regards to the web stuff, I want to like package everything in terms of a single WASM file, and so I kind of did that. I've done that previously. Yeah, so let's say, so in particular, I'll be going back to this, but in later streams. But we made a bunch of WASM examples. What was it called? I think this one, yeah, the Zig Web GL WASM examples. This is actually, it may be easier to just view this on GitHub. But yeah, we basically like programmed it in such a way that almost all the code was in Zig, and then we press a button, all of the JavaScript code is automatically generated, and then we get the stuff on the web. Yeah, so how do we build this? Okay, Zig build project. So if we say Zig build help, this will say what I think we should just use like Zig build fractal, but the name will be in here. Yeah, Zig build fractal. Zig build fractal. And then navigate to Zig out bin and then host a web server, Python MTTP server. Okay, so Zig out bin, oops. Yeah, so like basically all of these like JavaScript files here have been automatically generated, but the important thing is we have this fractal. Basically all the code is in a single WASM file. So now if I launch a HTTP server here, no, I think Python should be fine with this. Or was it localhost 8000? Yeah, we now generate this, and so like ultimately with the Z code we do kind of need to call some kind of JavaScript stuff, but we're doing it all within like the control of Zig. And so for the Zig WASM examples, if we just navigate to the stuff here, like if we check out like the index HTML page, this is it. Like the HTML page for this is just minimum because because like by design. Right, if we do, where's like the inspect page, view page source, here it is. Right, it's just like very, very simple. And then for the JavaScript for this, again, it's also like it's extremely simple, right? Like this kind of JavaScript code is not associated usually with something like this, because we've loaded everything into the WASM. It's just saying like fetch the WASM, and then other JavaScript code I don't exactly understand. And then this Zig JavaScript bridge extract, this is all of the JavaScript code that like handles with communicating with the WASM and back and forth. But all of this is generated automatically. I don't touch any of this. This was generated by the Zig build function. And so yeah, and so for it feels like it's been so long since I looked at this. Yeah, and so then in the Zig code itself, let's see, in this fractal example, yeah, it's just like when we did need to call these JavaScript functions, there are things like the JavaScript function itself would be like clear color. Like these are in some sense the WebGL functions, like the clear color WebGL, but we're doing this within the WASM with complete control. Like we can say, we can compute ahead of time what all of these values are within Zig without needing to use JavaScript. Likewise, like yeah, we can just like we can perform casts of values and actually know what we're doing. Like casting values in JavaScript is I've had historically a very bad time with it. And in Zig, you have total control over it. In fact, the control is forced. Like Zig will say no, I'm not compiling that if you're a bit unambiguous. But yeah, so we'll get back to all of this stuff eventually down in later streams. But yeah, for the moment, just doing it in Zig. We'll then port that, and then yeah, because I think there's something very powerful with being able to with not having to worry about the current latest like JavaScript ecosystem. That's something I want to avoid as much as possible. And so by just packaging, if your only point of like failure is like the how things work in the WASM, that's way easier to think about. And then since the Zig compiler targets WASM, that's always going to be taken care of. And so by then writing all of the code so that it's like inside of the WASM, the likelihood that something will fail in the future is massively reduced. And then if it does fail, it would just be a matter of like, it'll be some bug in the Zig compiler, and then it will get updated. So yeah. Okay, so then back to let's see, back to this sliding puzzle example. Zig current build run. Yeah. I've been where I said, yeah, vanilla JS is not that bad. Also, there are problems with multi-threaded code in WASM. This is true. However, I think in my case, the rendering will be simple enough that I don't need to worry too much about like the multi-threaded stuff. But yeah, and certainly, but the Z compiler itself is something where, of course, there's already a lot of multi-threaded support, but it's something where the core development team wants to in some sense, like, the design of it isn't finalized, and they want to revisit the design. And I imagine at some stage part of that conversation will be kind of like WASM multi-threading as well. But we'll see. But yeah, I need like a lot of type safety. I need a lot of control. Yeah, I want like control over like memory layouts where these things are more difficult to do in vanilla in JavaScript than in a systems programming language like Z. Okay, so then in terms of this shader, we're almost done. We just need to specify. We now need to use this data we've passed in. So we've got our texture color. Then okay, this is the line we need to rewrite. So the well, almost. Okay. So let's first just define the. I want to call like the solid color, or just like the. Call it the flat color. So the flat color is just going to be the color, but with the now normalized. Then the interpolated color will be the texture color and then the flat color. But we're doing the texture so that a lambda value of 0 is equal to the constant color, which is what should happen in here. Okay, so let's try and compile this. There's going to be errors, but we'll see. We'll see how bad things get. In main, in 184, color texture vertex. That should be color texture vertex. Color vertex buffer index 416. Oh, yeah, this is now changed to just the vertex buffer index. Oh, no. If we're drawing the background triangles, where is this in? No, if we're rendering the background here, this should be, why isn't this constant? This should be a 2. Oh no, this should be a 6. How was this rendering before? Why is... Yeah, that should just be a 6. Okay, 4 to 7. Use of undeclared identifier, texture shader. So I think, yeah, the other aspect with like the vanilla JS is just the performance. Like the performance of the WASM is significantly higher, and so you've also Zig will also whereas like in JS you have like a lot of the code is checked at runtime. By compiling it in Zig in a WASM, so much more of the code is checked at compile time, and Zig will immediately fail you for errors that will fail you for errors that would otherwise run and be buggy in JavaScript. And so in this way, you're picking up more bugs on the compiler level by just making the WASM in Zig than doing it in vanilla JS. Like certainly there's a bunch of vanilla JS tools you can use to kind of do this, but I'd rather just feel like Zig is a solid rock. I'd rather like tie my it's just like I'd rather my anchor be underneath that rock than like perhaps in like a sand, like than the sand. Although I don't have much maritime experience, so that analogy is probably flawed. But yeah. Okay. 47. Undeclared identifier texture shader. Yes, this is now the color. Yeah, the color texture shader. 434. This is just the vertex buffer. And 491. Color.debug. Oh, this should be colors. We've got a vertex shader fail here. What is failing? Lambda undeclared identifier line 14. Oh, I guess because it should be capitalized. Okay, so the interpolation is working, but clearly many other things are not. But this is okay. We'll figure out. We'll get this thing working. Like an arrow. Let's just save what we've currently done. Which is, there's been a lot of changes, and then we'll come back to it. So let's say rewrite code to use only two shaders, but now buggy. Okay, so yeah, so where to begin? Seek out. Sliding puzzle. So yeah, the fact that everything's starting off at this corner, telling me that some of the coordinates have just been offset into the wrong places. So maybe in the vertex color shader things are off. But we never really modified any of this kind of stuff. All we did was just pass different values around. I'm also a bit confused with these colors, why it's this kind of why is this sort of cyan? Okay, so maybe back in main we've got I feel like something must be wrong with this draw color texture rectangle. Okay, so let's see. Unless it's like the position of these are offset weirdly, like maybe in the setup array buffers we've ruined something. So yeah, the background is uninterrupted. That of course is fine. It's just with this stuff. Is it this? Have we done something here? Oh, right. All of these should not be 4. No. All of these should be 8. Okay. No. Compile. Great. Okay. Much better. Significantly better. Okay, so we are kind of getting this interpolation, but weirdly one of the corners is yellow and the other corner is not yellow, and not all the tiles are being drawn, which is weird. But maybe that value that I chose to be 6 like shouldn't have been a 6. Because yeah, in particular, if we consider how many rectangles are being drawn in this tile, it's 4, and then we're like half of one here. So actually, I don't know why we're just getting half of the tile. Why? Yeah, that to me is unclear. I'm a bit also concerned that the border isn't like a fixed color when it's being interpolated. Okay, let's change this. So instead of making the lambda vary, let's fix the lambda to be, what do we say? 0 was the color. So if we set it to be 0, and then recompile it, we get this. So I can't even determine where the hole is, but the hole should be at the top here. And if I press down, or rather up, it's here. Okay. Okay, so let's, yeah, so we're clearly not drawing all of the tiles. So jump to the render. Yeah. Oh, there's another. Is this another magic value in here? Yeah. The size of the buffer sub data we're pushing is meant to be 8 times the vertex buffer index, not 4. This is yet another way in which the magic number is biting me. Okay. Figured it out quickly though. Okay. The tiles are back. The rendering, the animation is fine. But the border is now not a solid color. It's being interpolated between this blue and this black. Why? It should just be constant. And likewise, this background one is between yellow and white. Why? What's going on? Like, I'm not strictly speaking opposed to having a gradient in like the background color, but it wasn't what I was expecting in my head. Okay. So in terms of the shaders, let's go back to the fragment color texture. Well, hang on, yeah, this shouldn't be a shader issue. It should just be like a vertex color issue that we're pushing different stuff. This couldn't be an alignment issue, could it? Okay, so these gradients are not varying on the vertical level. It's just simply on the x coordinate. So the background, which is meant to be white, it's like missing. If this is yellow, then it's what the yellow is. The red plus the green, so it's missing the blue. So the value for the blue here is 0. It suggests to me there's yet like another alignment issue. Let's see, if we go to set up array buffers. Oh, yeah. This is not meant to be a 3. This should be a 2. Okay, way better. This is... Okay, so now we've spent an hour and got back to where we were to begin with. But the code is massively simplified, and now, most importantly, we can activate this lambda and really sort of change it. So now we want to set the lambda to be this variable thing. Okay, so now, okay, so now almost working. So this is kind of what I wanted for the win state. I wanted like the grid to dissolve into the background. It's almost doing this, except that these tile borders are failing. But that's because we haven't actually calculated the geometry for them. That was something we were going to push until later. But otherwise, this is working. Yeah, I think this will be a cool win state when everything kind of dissolves, just to have the image of the Earth. Also, when we have the win state, we want to make the dots in the background shrink as well. So a couple things to do. But yeah, let's save this for the moment. And this time it was just adjusting pointer offsets. Git add, git commit. Got and animation and grid animation fade almost working. Okay. I want to just like adjust the dots in the background, so we can just get that working after all of the rewrite and debugging. So there was a radius somewhere that we had the to-do on. Yeah, this was it here. To do, make the radius go to 0 when the puzzle is solved. Well, let's do this. When the puzzle is solved, we'll want to save that as a timestamp, and then we'll use that for the animation. There's still a fair bit of work left. It's all right. We will get through it. So program start, timestamp the frame, and then the win timestamp. Also make this a U64 undefined. And then when we do the is1, yeah, if it is 1, this is, we don't want to like invalidate this, but I think we don't yet need to do this. I think we can just, if the plan is to lock the puzzle pieces, then it should be solved every single time anyway. Okay, we want to okay, if assuming it isn't 1, we want to check if it's 1. Otherwise, and then if it is, we want to set the timestamp. Did I not just refer to this as the timestamp? Win. Maybe this should be called the one timestamp. The one timestamp to rule them all. One timestamp is equal to, we'll set this equal to the frame timestamp. And then we want to use this to calculate the dot animation. So when the puzzle is solved, we want to set the radius to be well, to go from this to 0. There should really be called a constant called like win, like one fade, like one animation time. We've got the animation sliding tile time, and then animation one time. Let's make this like 3 seconds to begin with. Oh, this is like the logic required here just becomes complicated. I mean, it's all right. We want to do second since this is going to depend on if it's 1 or not. If I think we want to switch on I think a switch is the easiest thing here. So yeah, so we'll say the constant radius value is equal to a switch, or we'll make it an F32. And we just want to switch on is 1. If it is false, set it to be this thing. Otherwise, we need to calculate what it is. So then we want to we have to use this like block syntax that I'm not a huge fan of. Maybe it is better to do this in a different way. Maybe it's better to say animation. I think it would make sense to have a global, like 1 animation fraction, since we're going to need it to update like the lambda in a couple of places. Oh, but then if we're doing it here in render, maybe we do it here? No, we're going to need to know this when we draw stuff. So we need to know it when we draw it here. Yeah, let's I think the only place we need it so this is not the case. Yeah, let's make a global called animation, called like win animation fraction. Oh, this is already like we'll continue. This is like more complicated than I want, but we'll move on. Yeah, so for the globals, well, it's better to have it in the animation. Okay, so we already have an animation fraction anyway. What do we... Oh, this is for like the tile animation fraction. Ooh, we're gonna have to rename this. So let's call this animation tile fraction and then animation 1 fraction. So, okay, when do we update or calculate this? Oh, we don't, let me see. We currently want to replace all instances of animation fraction with this animation tile fraction. Okay. And now for the radius, we want to be computing the, we want to be using the animation 1 fraction. But let's compute this a bit earlier. I guess we can compute this in update state. So so yeah, if something isn't 1, we compute to see if it is, and then if it is 1, we want to calculate the there's a couple of like if-is ones we want to do. We want to set the timestamp here. Okay, and then if it is, we want to calculate the fraction. So now we want to say seconds since 1. This is equal to this delta timestamp delta 2 seconds. 1 timestamp frame timestamp, and we want to use this to calculate the animation 1 fraction. So then what was the constant we defined for the animation time? It was animation 1 time. Okay. So we want to say we want to like clamp the time 1. Animation 1 fraction is equal to, I think, standard.math.clamp. Oh, is this an intrinsic? I don't think it is. It may be in standard.math. the variable and then the limits. Okay. So the second since 1, then the limits. We want to move this between 0 and animation 1. One time, and then divide that by the animation 1 time. Okay, and then finally, with regards to the radius value, we want to set this equal to, well, we can make this even easier. It's just this value times times the switch, which is if it's not 1, we get the entire thing. Otherwise, it's 1 minus the animation 1 fraction, and then yeah, okay, and then that's the thing we'll push. Okay. Okay, so then if we win the game, things don't change. Unfortunate. We somehow got an integer overflow. What? Let's just do a debug print of this. Oh, silly. It should be frame timestamp and then the 1 timestamp. Okay. So at least the size of the stars have reduced to almost nothing. But those are also not 0. And it's meant to be 0. Okay, so let's say we solve this. Slightly annoyed that when the radius is 0, pixels are still being drawn. Oh, I think this is because of the smooth step. Yeah, smooth step is still... Actually, maybe that's okay. Maybe we can leave them there. Something in the background. But in either case, the animation is not working. They're not getting shrunk once it's 1. Yeah, why not? Yeah, particles could make a fun win condition, but this is just like, this is a simple exercise so that I can to build up on top of for the other projects. Yeah, I'll do a particle system some other project later. Yeah, so weirdly we're not like updating what these radius values are, unless the tile sizes are being calculated. Okay, like what? Why? Is it because the animation 1 fraction is not being updated that much? Yeah, that must be what it is. We should be really updating this every frame. Oh, this is the problem with having like a return here. I knew this was gonna happen. Okay. Ooh, how are we gonna lay this? I feel like if we just move, we can just move this to the render part. It feels a bit weird to be like adding this in the render instead of updating the state, but whatever. Technically, I guess we shouldn't be. This draw grid geometry function should also be factored out. It doesn't actually, it's fine in here for the moment, but it doesn't need to be in here. Yeah. Okay. Now things are shrinking, which is good. Let's get rid of this debug rad line. And then, yeah, this draw grid function should be, I feel like it should be elsewhere. It's fine. So now we want to change the lambda to use this animation 1 fraction. So in the draw grid geometry, when we set lambda here to be this thing, we want instead for this to be animation 1 fraction. Okay, and then I think, great. Almost done. And so we'll also need to lock the keys, but I'm liking this as like an end to the game. It's just when you win, everything just fades. Okay, let's save this, and then next time. Got synced up fade to animation fraction to 1 and animation 1 fraction, And then I think there's some other stuff actually we should just clean up in the code right now while we're at it and remember. For one, there's like a bajillion temporary files. Not that we're saving them, we can get rid of them. So I think we want to get rid of this vertex. We want to get rid of the fragment flat color and the vertex flat color. And anything else. We can actually get rid of this vitiates, I think. Oh, actually, maybe it's good to have it separately. I don't know. Depends on. Actually, it doesn't. It causes us no harm to keep it in here. Oh, but then it's already in the code itself. It can go. Vitiates. Let's just check that this still builds. It should. Windows. Okay. Good. And then, no, I'm not using Win BG at the moment. Yeah, I'm just when I do use a debugger, I use the remedy. This one, remedy BG. It's a whole like this one isn't free, but I find it already has like a lot of Zig compatibility. Where is it? Sliding puzzle. Zig out. And then yeah, it basically like immediately. Once you add in the source, .zig, you can like step through the assembler and issue breakpoints and see the assembly and everything. So like say like we wanted to stop this on a breakpoint if we win the game, then you can start like debugging and then the game's won, and then you can sort of step through the assembly here and see it has like basically most of the features you would want from a debugger, but it's like super fast. It has more features than say like Windows Visual Studio and some other things. See, this is the one I like. So yeah, that built. It deleted some old files. We can also get rid of this, like, maybe I can just do the git thing now. Okay. I could probably get rid of the IO example as well. Yeah. And then what else? Photo. Oh, we need to keep the photo link. We'll probably incorporate the colors.zig into the code.
Okay. But yeah, otherwise I'm happy with the progress today. We massively simplified the shader code. Now there's only the background shader, and everything else is covered by a single shader. We've got an animation working in the game that basically that plays when the game is won. Next time we'll just need to lock the puzzle pieces so they don't move when the game is won. That will basically be trivial. We'll need to compute the geometry of the border segment so that they also everything fades into the image of the Earth. That itself should also be really easy. And then it's actually, now I'm like looking at this, I'm wondering if like the offset calculations are incorrect in some way. Like there seems to be some slightly weird alignment with some of these. Anyway, we'll be able to figure this out next time. Yeah, I feel like there's going to be some alignment issues. Oh well, we'll do this next time. We might add in like some other kind of message. I can access pieces in the shader. No, like the shader itself is just the coordinates are just we calculate the coordinate, like there's a single texture, and you're welcome to all of the code is online. You can check it out if you're interested to see how it works. But yeah, if you go into repository, if you just go GitHub / loaded and then go into the sliding puzzle in Zig, all of the code is here. And so in particular, in the shaders, you can just see the shader worked on today. The texture coordinate is being passed into it, and that coordinate was is calculated in main.zig in the draw grid geometry function. That itself, we pass it in to the buffer that we push to the GPU. So we pass in these two vector 2s, and then that's what the shader uses to draw the coordinates. So yeah, all online. What's this? But yeah, thanks for dropping by, and yeah, there'll be more updates with my game and other things soon. So, yeah. Thanks for dropping by. I'll see you later.